all swans are white. The moment that somebody comes along and they show you one black swan, this statement is no longer true. You can't say that. If all swans are white, so let's assume all swans are white. And then I say, well, hey, Reggie is a swan. I guess because of that, I could assume that Reggie is a white swan. So that's logic. I always enjoyed those logic problems where you had to deal with, Alfred, Bernard, and Charles cannot sit by, people with purple hats. This guy wears purple hats. And you had to kind of reason out, like, who went where. So all of those different things are all about logic. And we're using reasoning, like, to reason through different problems. And that whole black swan example I gave, that is a counterexample because it disagrees with it. So this is going to outline logical reasoning and counterexamples. So a conditional statement, well, anything that's conditional is it depends on something else. So it's like, okay, you guys get to leave early today. By the way, this is not true. On the condition that everybody else works hard for 42 minutes. Well, if that ends up being the condition, then you end up getting rewarded. So the whole deal is, we can write this as P then Q. So go ahead and off to the side write P, a arrow Q. And here's the deal. P is the hypothesis, so if everyone is well behaved and works hard for 42 minutes, then, here's the then part, Q is the conclusion. Well, everybody would get to leave early would be the conclusion. Now the words can kind of get a lot of in the way, so let's look at these together. Identify hypothesis and conclusion. So in these conditional statements, we're going to have to identify the hypothesis and then what the conclusion is. So the hypothesis is the beginning part, the hypothetical part. So in each of these problems, let's label the hypothesis and conclusion first, like this. So first of all, the hypothesis, conclusion, go ahead and give yourself a moment, pause the video and get that written down. So if it is Friday, well, that's the requirement. So if it is Friday, well, big deal. What happens on Friday? Well, according to this, then Ophelia and Miguel are going to the movies. So we would actually rewrite all of this. So based on this, make the second problem an OYO problem. Pause the video and then I'm just going to have the results up. So here you're just pulling out the first part and then the second part. And if you did want to check this, 4 times 6 is 24, plus 3 is 27. So that's right at the border of that, and that makes sense. But we're not told to test these. Here we're just told to identify the hypothesis and conclusion. So this is just about a couple of different vocab terms. Second type of problems, not second type, make these also OYO problems. I'll put the answers up. And instead of rewriting hypothesis and conclusion, I am okay with you writing H and C now that you've written it a couple times. Answers will be up in 4 seconds. Obviously, I want you to write the whole thing out, but here is the hypothesis, conclusion, hypothesis, conclusion. With these, you can kind of like figure out what feels the most comfortable. So we have to write a conditional statement. So something is going to depend on something else. It's like if A, then idea B. And so this has to be an if-then form. We're told to identify the hypothesis and conclusion, then write a statement in if-then form. So hypothesis, conclusion. Well, let's think about this. I will go to the ball game with you on Saturday. What feels more natural? If I go to the ball game with you, then it is Saturday? Or if it is Saturday, then I will go to the ball game with you. Which one feels more natural? And I think you could probably argue this one either way. So here, if I'm going to the ball game, well, let's just make that the hypothesis. And let's make the Saturday here. So if we turn this into a conditional statement, if I am at the ball game with, that's W/, that's a shorter way of writing with. If I am at the ball game with you, then it is Saturday. But we can't overthink this one too much, because it's not like, oh, if I'm at a ball game with you, it's not like it's always going to be Saturday. Also, it's not like if it is Saturday, then I'm at a ball game. It's not always going to pan out that way. These ones feel a little bit more natural. So let's go on, do one together, and then the others I'll do OYO. So for the hypothesis and for the conclusion, for a number x such that 6x minus 8 equals 16, x equals 4. Well, let me try it in different order. Well, what if I were to say, if x is 4, then this? Well, I could come up with anything that I wanted if x was 4. So I think it's more natural to treat the first equation as the hypothesis part. Like, if this is true, then x has to be 4. And again, you probably are given ones that work out, but 6 times 4 is 24, minus 8 is 16. So that does check out. And if you haven't noticed the pattern in how I'm writing these, if precedes it, it comes before. Here's the hypothesis. There's always a comma. There's always the word then. And then lastly, the conclusion. The next two will make OYO on your own. So in another 4 seconds, I'll put the answer up. Pause this and finish them. This one I did choose to rearrange. And I did choose to rearrange this one because I think it feels more natural to say, if she is swimming, then she wears goggles. And, I guess you could take this to a silly point. You could be like, well, if she is wearing goggles, then she is swimming. Well, she might be outside of the water. Whatever. You want to be particular about these, but not like insane. In number 4, I have the rhombus has side lengths of x minus y units. Then the perimeter is 4x minus 4y. Now this one actually, you could have a different shaped rhombus that has different labels. So in this one, it has to be in this direction. And so as I write the sentence out, if a rhombus has side lengths of x minus y units, then its perimeter is 4x minus 4y units. Take a moment to get caught up, and we'll stop this video here before moving on to the second types of problems.